Hello everyone, welcome back to Homeport. We're going to see a demonstration from Matternet in a few minutes. Just a reminder, this is being live streamed. You can also watch the recordings or share them as you like through the ITS World Congress page. Before we jump to Matternet, we're going to have a short talk from Christoph Stoll from DFS, who's going to be talking about the safe air traffic management system they've been using to help facilitate and support the demonstrations this week. So I'll hand over to Christoph now, and then we'll hear from Alex Norman from Matternet. Okay, Christoph?
Yeah, thank you very much, Louis. A very warm welcome today and a very good afternoon to every one of you who has made it out today to the Homeport area to view the live demonstrations that we are holding. And well, we are very happy to be here today. And like Louis said, my name is Christoph Stolle and I'm with the DFS Deutsche Flugsicherung, so that's the German air navigation service provider. And there I'm in the Department of Corporate Strategy and Organization. So I'm mostly working on subjects that are related to digitalization and innovation. And of course, unmanned air traffic is one of them. So I'm very happy that today I have the opportunity to briefly talk to you about our UTM system that we're using in my capacity as the project manager of the U-Space sandbox that we've recently installed here in Hamburg. And our UTM system is the first fully operational system and commercialized one in Germany. So UTM, that stands for the traffic management of the unmanned aircraft systems. And these two things together, so our system and the European U-Space concept, will in the future ensure that even a large number of different applications with drones can be performed safely and in coordination with manned aircraft. And that's what we start with right here today. So before I want to tell you a bit more about what it is that we're doing, I would like to draw your attention not directly towards the sky, but let's just stay here on the ground for just a minute. To be more precise, let's look at the streets and the roads. Because in the streets we have a large number of different participants and users. And we have cars, buses, motorbikes, bicycles, we have e-scooters now, and we have pedestrians. And of course, there's a set of rules in place in order to safely manage that traffic. And the situation up in the sky is really quite similar, only that the rules there, they're not always immediately apparent to everyone. So when we tend to look up, or when we look up, we tend to only see first the open, free, unlimited sky. But of course, there as well, there are certain rules in place in order to safely manage that air traffic. And this safe management of manned air traffic has been our business for decades now, so we're good at that. And now with the introduction of a new airspace users, the unmanned vehicles, this traffic management system is approaching a new era. Because now we don't only have manned air traffic, but we also have unmanned air traffic. And these unmanned vehicles, they have a completely different set of capabilities and needs regarding their operations, and they want to use the same airspace. So that creates the necessity to amend the existing rules. We need to bring the two worlds together in order to have an integrated operation and to ensure the safety of everyone that is involved there, and that's what we want to facilitate. And in order to solve these arising challenges that come with that subject, the DFS Deutsche Flugsicherung and the Deutsche Telekom have founded a drone specialist joint venture called Dronic in 2019. And our joint task is the safe and fair integration of drones into the airspace. And you may now ask yourself, well, how does this actually work? And one very important aspect of it is as simple as it is important: visibility. So visibility is paramount. We need to have a live and reliable picture of the situation up in the air in order to ensure safe flight operations. Because one important thing that unites the both traffic systems, the one on the ground and the one up in the air, is that, of course, in order to follow the set of rules, you need to know the rules, but you also need to know every participant that's in this traffic system around you. And to create this visibility, we need to find a way to make everything and everyone visible. And that actually is quite a challenge, because drones are usually too small to be recognized by traditional radar stations. They're also too small to be seen from the cockpits of manned air traffic. And if we put ourselves in the shoes of a remote drone pilot now, who doesn't actually have a cockpit that he can look out of and sense and avoid other traffic. So we come to the conclusion that we need to make everyone visible electronically. And that's especially important if you think about operations of the remote pilots that take place beyond the visual line of sight. And that holds true regardless of any specific use case. So may it be agriculture, energy, something in the health sector, logistics, or the transportation sector. We need and we want to make sure that everyone flies safely. And that's why our traffic management system supports authorities, operators, and drone pilots during all phases of the flight. So that's pre-flight, in-flight, and post-flight. And that with functionalities like flight planning, flight authorization, the conformance monitoring, we have traffic alerts, and in the post-flight sector, we have the documentation and the incident management in case there have been any incidents. And well, now how do we achieve this visibility? Well, we employ parts of the German air traffic control system and also of the Deutsche Telekom's mobile network. So all the information about the manned air traffic that comes directly from the DFS systems. So that's verified and reliable. And all other traffic data, especially the one from the unmanned traffic, is collected by special UAS hardware that's developed by Dronic. And one way, there are many ways, but one way to make the unmanned traffic visible is the mobile network, so 4G or LTE technology. And there you have basically two options. So either you have a drone that's already LTE ready that can be hooked up to our system via our API using our ICD, and your data flows directly into our system. The second option, that's actually the option that Matternet are using today. So their drone is LTE ready and is connected to our system and communicates directly with us. And the second option is that you use one of Dronic's hook-on devices, like this one here. So you can think of it as a flying smartphone. So it forwards its position directly over the LTE network into our system. But it does not only do that, it also collects all the air traffic in its vicinity and forwards the data of all the other traffic that it recognizes directly into our system as well. So you can think of it as a flying eye as well. In addition to that, it also broadcasts its position into the avionics of the cockpits of manned aviation. So if you put everything that together, what I just said, you end up with a situational awareness web display for the drone pilot that includes all the traffic that's up there in the air and enables the drone pilot to fly safely because he knows where he is and he knows where all the traffic around him is, and that even beyond visual line of sight. And you will experience that in a minute when a demonstration of Matternet starts, and you can have a look at this situational display. All you need to do is take out your smartphone and scan one of the QR codes that are on the flyers that are laid out here, and you will be directly forwarded to a very basic version of our situational display where you can follow the presentation online while you're watching the drone that's flying in the sky. And that's possible, like I said, because Matternet is directly connected to our system. So at this point, thank you guys again for this opportunity to use this day today to present your drone and also to present our system. So that's it from me so far. If you want any further information about our current activities, I kindly welcome you to have a look at the DFS or the Dronic website. We also have some information screens at the ITS, at the booth of the Federal Ministry of Transport and Digital Infrastructure. So if you're curious, you can check that out, get some more information there. And if you have any urgent questions, just feel free to approach me around here in the Homeport area. I'm very happy to answer anything that you would like to know. And now I want to hand over to Louis. And well, thanks to everyone for your attention, and I wish you always blue skies and safe landings.
Thanks very much, Christoph. So just as a brief introduction to the project that you'll be hearing about, it's a collaboration between Labo Berlin and Matternet. It's around transportation of samples between labs. To talk you through that and the demonstration itself, we have Alex here from Matternet. And then at the end, we will take some questions. So if anyone from the audience has any, just stand by for that later on. Alex, thank you.
Thank you very much. And also from my side, very welcome to the Homeport here and to our demo. Before we go into the demo, though, I want to explain you a little bit of what we're trying to do and what's actually our plan here. And to understand that, we take a quick look first at our use case that we have in Berlin. In Berlin, we are collaborating with Labor Berlin, the central laboratory of Berlin, which serves basically almost 85% of hospital beds in Berlin. And so it's spread around to 13 locations in Berlin. This central laboratory is analyzing almost 30,000 samples per day. So you can imagine that this is quite a volume that they need to handle every single day. And they're spread around with 13 sites for the hospital. So they need to come up with ways to logistically connect these 13 sites to this central laboratory. And nowadays, they do this obviously with cars. So a lot of road traffic, and essentially they're spending 400,000 kilometers per year on the road in order to fulfill these logistical networks. So we collaborated with the different stakeholders also in the state of Berlin, for example, also with the Senate, in order to enable this new technology in the city of Berlin. And we are still working on that and trying to establish basically a network that will fulfill that need for the laboratory. So that's also why we call our company that way, because we believe that at some point there will be a new layer of infrastructure that we call the Matternet, the network of Meta, so to say. And you could almost see this as a pendant to the internet, which is the network of information. We believe that at some point there will be a new layer of infrastructure that allows you to send and receive goods almost in the same way. So if we look at Berlin, we have the vision of creating an on-demand delivery network over the city of Berlin that allows exactly this fast, predictable, and cost-efficient way of transporting, especially urgent medical goods. So Matternet actually exists since quite some time. We started first operations back in 2014 in the country of Bhutan, and then from there started 2016 with the first beyond visual line of sight operations in Switzerland. Now we have operations across the world, which I will go to in a bit. So in order for this to work, the drone is just one piece. So Matternet has developed basically a suite of technology here in order for this to work in its ecosystem. And the first pillar is the platform or cloud software that we are developing in order to for this to work together. Then obviously we have the drone, which is one important puzzle. And then the station, which represents basically the nodes of the network and allows us to receive and send goods also asynchronously. And the last piece is the mission control unit, a unit that allows us to supervise all flights that are happening in our Matternet, essentially. So all of this is linked through the cloud platform, and here you also see how we are connected to the dronic system, enabling us to safely integrate the drone into the airspace. So receiving data from DFS to dronic and then to our mission control. In the future, we want to have all of this fully automated and only supervise it through our mission control without having someone on site. The drone you will see flying today is the Matternet M2 that you can see here also on the screens and out on the platform. The drone can fly at a speed of about 70 kilometers per hour and a range of about 20 kilometers. We have installed a couple of safety systems as well, such as, for example, a parachute system that will automatically deploy in case the aircraft is departing from its designated route, for example. Furthermore, we are able to land on a 1 meter by 1 meter landing pad that you actually see out there on the deck. The drone is able to land precisely on this landing pad with its precision landing technology. Our mission control enables us to supervise multiple drones at the same time, and also the safe integration into the airspace. And as I mentioned before, also this integration with dronic actually enables us to see other aircraft on that mission control screen, and also alerts us in case we need to take action in any sort. Across the globe now we have different sites with commercial operations where we operate every single day. For example, in Lugano, in southern Switzerland, we have already accumulated more than 5,000 flights for the hospital system in Lugano. In Zurich, about more than 1,000 flights. In North Carolina, we have about more than 7,000 flights. In Kentucky, a little bit more than 1,000. Florida, a little bit more than 2,000. And all in all, if we also take all of our test flights into account, we are accumulating our flights up to 38,000 flights on this particular version of aircraft that you see out there today. So here you see an image of our operation in Lugano, Switzerland, where we fly over the city center of Switzerland. Of Lugano, obviously, and flying also outside of the visual line of sight. So that is something that's important and also not done widely yet. In the US, we are operating together with UPS, who is operating our drone as an airline, essentially. So they're using the same structure and same rule set that is used for normal airline operations. And with a special exemption, we're able to basically allow this airline to operate our aircraft. And that's also how you should see this operation, because it's not like what you may have experienced before, someone flying with a drone on the sticks. This is really different. It's really like an airline, and we also train and operate basically like an airline and enable this safe operations, essentially, also over a city. So what I want to show you next is a short video of how we envision this to work with the Matternet station. So what you see here is the first Matternet station, as it is also now installed in this city of Lugano outside the hospital. And yeah, without further ado, I will just play that video. So you can see basically that the hospital personnel can just drop a box into that station, and then the station will fully autonomously pack that station and pack that payload into the drone. And the drone will then, after completing its pre-flight checks, automatically take off once the mission control has given its okay to take off. And then the drone will fully automatically proceed on its designated path towards the lab location, in this particular case, where then someone will receive the box. So this is really completing the vision that Matternet has, and really enabling that fully automated delivery network also in an asynchronous way. So basically you don't need to wait for the drone to land, so you just basically go to the station whenever you need that payload. So also this enables us to automatically swap batteries and charge batteries, as well as store any payload for an amount of time, also temperature controlled. So in Berlin, we have this vision now to create this network and connect all these sites, hospital sites, to that laboratory. And we want to show you now how that looks like in the real world, essentially, as we operate nowadays, also in the different areas of the world. And the video that I will start now will show you how that process could look like with a landing pad like you see out there. So essentially, anywhere in the city of Berlin, for example, we could have such landing pads. And for example, here in the Charité Benjamin Franklin Hospital, we could have a laboratory that packs this payload, an important medical sample. For example, if there's a suspicion that there is a poisonous or someone who got poisoned, then this needs to be analyzed very quickly. So we are packing that blood sample into a payload box and then put the payload into the drone that you will see in a bit. And essentially, this station or this landing pad can be located anywhere outside the hospital. And then the personnel can just walk up to the drone and place that payload inside the drone and secure it safely with 4 bolts. So if you turn around now and look at the drone, our team has prepared the drone and should be ready any time. They need to conduct a couple of pre-flight checks and make sure that everything is passing its checks. So you see now the blinking lights. These are the anti-collision lights that also can warn other aircraft. And you see the drone taking off. You see, even despite the wind, it's coping quite well. It will climb to 30 meters above ground and then complete a predefined route. So again, you have a geofence that is placed around this path that the drone is flying. And if for any reason this drone would exit that geofence, it would automatically deploy the parachute. There's no one that actually flies that drone. The drone is flying fully automatically. And we are just supervising the flights as they're happening throughout the city through our so-called mission control. What you will see next is essentially the aircraft asking our system if it can land, because it is designed in a way that we can handle multiple drones at the same time. So we need to obviously deconflict also with our own drones. So we are basically asking our cloud system right now, can I land? And if the aircraft then gets that approval, it will proceed directly over this landing pad, essentially. So now it has received this approval and will start to look for this landing pad that you see on that deck, and will land precisely on this landing pad. Also notable maybe is that the drone is not very loud, and this is also due to the propellers that we are using. Maybe you have heard other drones prior that have a very high-pitched noise. Our drone has a much lower pitch sound, and therefore also it's more convenient, let's say. We're seeing the drone now approaching the landing pad and touching down and landing. So you see a very normal process for us, something that we're doing every day. And now I will answer any questions that you might have.
Thanks, Alex. So great to see the demonstration go smoothly. If members of the audience do have questions, please make yourself known and raise your hand. But in the meantime, I'll ask a few I have noted down here. So obviously, it's quite a windy day. You've been able to fly sort of impressively in these conditions. Up until what point can you fly, and what are the sort of contingencies in place if you can't?
So we have tested our drone now in quite extensive weather conditions, and we can fly up to 8 meters per second sustained wind and 12 meters per second gust, which is quite a significant amount of wind. And additionally, we can also fly in medium rain, so also that is not an issue. The only issue that we do have, like also manned aviation actually, is when it starts, we need to start to handle icing, so rain or humidity and also sub-0 degrees.
Okay, and I know that you've also had or currently are deployed in, I think it was Abu Dhabi. So you've got different weather considerations there. How do you deal with those?
Yeah, right. So we just recently started operations or a test campaign also in Abu Dhabi. And in order to make that happen, we also went to Abu Dhabi prior to do an extensive campaign of testing to make sure we are also coping with these conditions. And yeah, it went well, and even in the 50 degrees Celsius heat, the drone was performing well.
Great. And I wonder, so in the event of a failure to communicate with the drone or something else, and say the drone is over an urban space, what contingencies are in place to deal with that as a situation?
So the drone has multiple safety systems basically, and one is we are not relying on the LTE to really fly essentially. We do rely on LTE to issue commands, for example, but the drone knows its path and will just follow that path. And even if we lose connection to the drone, it will just continue, or it will proceed to a pre-designated so-called safety zone that is somewhere along the route that it can then automatically proceed towards.
Great. I wonder if any people here have questions? Yeah? Yeah? All right. I was going to ask you, Alex, so in terms of if taking the Berlin project as an example, on average, how much time are you cutting from sort of the traditional courier route?
So, I mean, the couriers that are on the road today, if there's traffic, can take up to 75 minutes or something, more than an hour to get from the hospital to the laboratory. For example, if we take one of the hospitals that's in the southern part of Berlin, this is a very realistic time that they experience today. Our drone would be able to do this in 10 to 15 minutes, just by bypassing all the traffic and going basically almost like a crow's fly.
So have you calculated, over the course of a year or whatever, they're essentially, because you mentioned a figure for the number of miles that the couriers are driving. Have you done that as well with time? So on an aggregate, they see the marginal gains turned into significant gains.
Yeah, we looked at this very closely together with Labor Berlin, and we calculated essentially what that means also on the economical side of things. But the economics also are just one piece of this. Obviously, the benefit for the patient is what we're aiming to focus on essentially.
And linking into that, could you talk a bit about because you mentioned the idea of someone being poisoned. I know they need emergency labs. Can you speak a bit how that integrates with or the added value that you can provide in those kind of situations?
Yes, certainly. So basically, a lot of these hospitals nowadays need to have something that's called emergency laboratory in order to provide certain analysis basically as quick as possible. And the reason why, or one of the reasons why they need to have these laboratories is obviously because they cannot guarantee a certain turnaround time on some of this analysis. So if we could provide a new layer of infrastructure that allows allows these fixed times basically of turnaround and basically by knowing exactly how long the transportation time takes, we could rethink all of this, and we could rethink logistics in healthcare, and potentially could also centralize even more some of these laboratory services, and these emergency laboratories might not even be needed at that point. because they're quite expensive, also running 24/7 and with expensive machinery. So that's one way to see the benefit also on the economic side, yes.
Yeah, so if you can centralize the services into a single hub rather than having multiple hubs, then you're essentially saving time and money there. In the event that you can't fly, in terms of chain of custody for a sample, say there's a thunderstorm or something ongoing, what would happen in that event?
So we basically, as Matternet, we are trying to really provide a service to our customers and allow them not to worry about how something gets from A to B. So currently we also work with partners to enable, basically, in case of downtime, that there's still a transportation method available that can handle the urgent need.
Great. And I'm wondering, we've heard a bit about how sort of the dronic system in this environment is sort of enabling the safe flight, and I know that you guys have deployed in a number of different locations, some in the global south. Can you talk to us a bit about the sort of different difficulties or issues you've encountered in these different environments, and then maybe how these kind of new technologies are making it easier to deploy?
Yeah, certainly. I mean, especially in the global south, we do see that there's a huge problem, obviously, with infrastructure, all-season roads. I think it's about 1 billion people do not have access to all-season roads. And with such a system, obviously, we could leapfrog that and enable a completely new access, not only to urgent medical goods, but even a completely new way of even doing business, for example, in that areas, and allowing access to things that you cannot imagine it right now. Even for us, if we deploy such a system like the Matternet as we envision it, we probably can't even think about all the use cases and things that we would want to use this in the future. As we set it up and make it available basically also to the broader public, I think we will come up with ways to use the system that we haven't envisioned yet.
That's great. I think we have a question from the audience, so I'll just hand over the microphone.
Yes, thank you. I'm Michael from Holo, and we also operate some drones. But one of my questions is that whenever you're flying in a big city like Berlin, what is the biggest obstacle for actually getting approvals, or what do you do to make sure you can actually fly inside a very urban area? And another question is that how do the drone detect whenever it's ready to fly? Yeah.
Thank you. Yeah. So how do we manage to get approvals in cities to fly? So we're using obviously the common standards now in this industry, which mostly is what's called the SORA principle. That was developed originally by JARUS, but also EASA has now largely adopted that. So we're using this methodology to get to approvals. Obviously, as you can imagine, it's not easy, especially as regulators are starting to actually use that now, and we are probably amongst one of the firsts that are actually trying to apply this also in urban areas. And I think we are also uncovering certain things that are not written in a way maybe that they are super applicable. So we are trying to find ways to come to a good conclusion together with the regulators and also local authorities. For example, as I mentioned, in Berlin, we're working also closely together with the Senate in order to understand, what's needed in order to get to these approvals. And also another factor is obviously to work with the public and understand, the concerns that the public has and ensure that these are getting addressed. And that's so much about the approvals. For the drone itself, essentially, You have seen in the video that once we are packing the payload, or someone in the laboratory is packing the payload, they also have a tablet and they can actually scan the payload box. And when they do that, they create what we call a manifest. And on this manifest, a digital manifest, we have the origin, destination, and some information also about the package. And at that time, our system knows that this manifest exists and this package exists that needs to go from A to B. And as soon as the package then gets handed over to the station or then inserted into the aircraft, the drone automatically loads a flight plan and understands or basically checks, okay, which route do I have available that connects the two locations, and loads this flight plan. That flight plan actually then gets sent to the UTM provider, so that, for example, the Dronics of this world know where we want to fly to, and can also create the appropriate geofence. Maybe we can think in the future there's maybe also some prioritized services, such as, for example, medical deliveries. And then the aircraft also automatically checks all its sensors and making sure that there's nothing that's anomal. And once all these pre-flight checks, automatic pre-flight checks are passing, and also the flight director, as we call it, give the go, then the aircraft will take off and proceed on its designated route.
Thank you. I'm just wondering, you mentioned the possibility of other use cases that you can't foresee. Now, working on the lab use case has an obvious sort of cost-benefit analysis where you can quantify quite easily, okay, this is an industry where it would potentially make sense to use drones. In the past, there have been some analyses done about, it needs to be the point where the drone is comparable in cost to a motorcycle, for example, in the Global South. How far away do you think that is when we talk about other use cases? What could they be, and when does that sort of cost-benefit sort of point get crossed where it could start to be used for other things?
Yeah, so I mean, a lot of this is also connected to scale, but beyond that, if we think about the different use cases that there are in order to even to get to that scale, I think there's really a wide range of use cases, and especially once if you think about creating a network over a city that might be used for all different kinds of things, then I think there's use cases such as, for example, a more hospital, like to relieve hospitals, especially now with the COVID pandemic. We have seen that, for example, more and more healthcare is moving to homes instead of to the hospitals to relieve hospital beds, for example. So that could be one. But I would also not exclude some other use cases, or even go to a peer-to-peer distribution of something, you sending something important to your loved ones or something like that. So you could use, once the network is in place and the infrastructure is in place and you have this new layer of transportation in the city, I think you can, we will see usage, as mentioned before, that we probably can't envision right now. So to really understand how far we are from comparing the cost, it's really hard to answer that question. But we have some predictions around the number of flights that are needed in order, or the usage that is needed in order to get to that.
Okay, so is that part of the plan, kind of establish, say, 10 Matternet stations around hospitals in a certain city, and then potentially add to that network bit by bit, and then allow, I mean, where does the crossover, because I'm guessing at the moment you have exclusive contracts, obviously, with the lab, and so where does that fit in?
Exactly, yeah. So if you're looking, for example, at our most recent announcement about our deployment in Abu Dhabi, you will see that the plan there is to deploy about 40 different locations in the city of Abu Dhabi and connect some of their critical health infrastructure, but then definitely open it up to other use cases, also within healthcare, but some of the ones that I just mentioned before, and really start to use the system in different ways.
Would you see that as pay-per-use or sort of ongoing contract type thing?
So there's different models, obviously, but we would definitely start more of a subscription-based model, probably, and then depending on the service level that you're buying into, you might pay more or less.
Great. We've got another question from the audience. Here we go.
Sorry to be late. I gave you a call before arriving here. Alex, two points I'd like to address. First of all, when you started off your business, as far as I know, you sort of concentrated on rural areas, so long-haul flights, serving rural places, etc. Then you swapped your strategy and to concentrate now on urban environments. Where's that switch? Point one. Point two, I think you developed, maybe you talked to the people already about this, but I just came in. You concentrate on a new variant of a model of a Matternet drone. Can you tell us a bit more, a larger version, or what is all about your new project there? Would be interesting to know. Thank you.
Thank you. Yeah, so we started like so many other drone companies, also first in the global south and more in rural areas, actually. And also in Switzerland, our first flights happened in a rural area. But the need that we saw is actually very, very, big, especially in cities, and overcome this infrastructure problem that cities have. We saw a niche there where we saw ourselves working best in, and so we kind of pivoted towards that, and now this is our goal, essentially, to operate in the very urban areas and provide this new layer of infrastructure, especially in cities. Yes, we are developing new technology on all different fronts, essentially, and also on a new variant of the Matternet drone. Essentially, is something that we're working on, and I think we still need to wait a little bit on that, but roughly it will be able to carry a little bit more payload and have a little bit more range.
And I guess that's kind of linked to the choice to go down the quadcopter route rather than a VTOL, right, as well, in terms of distance and range, this kind of ability.
Correct, yeah. So the design decision, essentially, to go with that design has to do also with its agility and ability to land in very urban spaces, yes.
Okay. Another question, no worries.
Being a journalist, I'm persistent. So you talk a little bit more of further range, a little bit more payload. Could you be a bit more specific on this, please?
Well, I'm sorry, but I cannot yet be more specific. Unfortunately, you need to be a little bit more patient for us to release the actual design of the drone. The time frame will be, we will, until we will release that aircraft, it's a little bit more than 1 year still.
And maybe linked to that sort of future planning, you said that a single station has been deployed in Lugano now. When are we going to see Matternet stations in Berlin and in Lugano, like more widely?
Yeah, so we're working on deploying more stations as we speak, essentially, So we have just very recently, 2 weeks ago, basically started operating with that station in Lugano, and we're now making our first experiences basically in the real world. We obviously have done a lot of testing on this before, but now having this station in the real world obviously gives us a lot of additional insight and also the possibility to improve any, the future stations. And but the goal is clearly to move to this fully automatic delivery, essentially, that allows us to fly drones back and forth even without people on ground.
Well, if you're dealing with, say, we saw in the video, the roof of a hospital, what's the advantage of having a station in the hospital grounds versus going to the roof? I mean, I'm guessing access to the hospital roof isn't particularly easy anyway, so is there much of a gain there, or is it more for the future sort of planning of having something more on the street?
I think there will be different types of stations in the future. So we will have probably, a roof version and a ground version, and depending on the use case and the needs and the requirements of the different customers, we might have different stations. So this is almost probably the most complex version of a station. And you could imagine, now taking the station apart, you can slice it essentially and just say, okay, we only need the hangar, for example, on a roof. And in another area, we might actually not need the hangar, but we just need the lower section. So basically what you see now in Lugano operating is probably the most complex version, and then we might be able to have different versions for different customers.
Okay, and then in the event where you have, say, 20 drones deployed in a city or something, where do they wait? There's extra capacity in the stations where you have multiple drones, or are they sort of being stored somewhere and then sent off as the demand in the network sort of becomes apparent?
Yeah, so it's a little bit more your second description actually. So what we envision is, because we're using a network, we will make sure that this stays distributed essentially. But also, if there is a need at a certain location, we might rather add a second station and distribute that, and also maybe enable another node rather than creating one huge drone port. But also here, it would probably depend on the customers and see what the demand is and what we're trying to achieve, and therefore then work with those requirements.
Great. Are there any other questions at all right now? I think if not, we'll wrap up this session. We'll say thank you very much to you, Alex and Matternet, for the demonstration. That's actually the last air demonstration of the week. So thank you very much to Homeport and the Hamburg Port Authority for enabling this environment. Thank you to Dronig for helping the safe flights. Thank you to AllDots as well, who have been involved in the sort of general organization. Thank you very much, everyone, and have a great rest of the week.
Thank you.